Good morning, everyone, and I welcome you all to today's lecture. Am I audible and visible to all of you?
Yes, sir.
Okay, this is lecture number 9 in the topic of lenses. And just to have a recap of what we had done in the previous class, can anyone remind me of that?
Lens, convex and concave.
Okay, what else? We had done the Lensmakers formula. Do we remember the Lensmakers formula?
Yes, sir.
What was that Lensmakers formula? If you have to look back, that is not a good sign. 1 by f is equal to mu minus 1 into
1 by
1 by
R1
r1
minus 1 by
minus 1
R2.
by r2. Not a good sign. If you had to see, it's a very, very bad sign. Anyways, mu here was what? What was mu here?
Refractive index.
Of what? Air,
Lens.
atmosphere, huh?
Lens.
Refractive index of lens. That's it. With respect to what? Refractive index is a relative term. Refractive index of lens with respect to air, vacuum, atmosphere, hydrogen, nitrogen, what? See? We are back to square one that we don't remember it. So now you will have 5 minutes to go through what we had done in the previous class, because if you don't remember what we have done in the previous class, this class is going to be a waste. So 5 minutes, go through what we had done in the previous class. Is 5 minutes enough for you to go through?
Yes, sir.
5 minutes. Steady, everyone. Look at the Lensmakers formula. Why I'm insisting so much on the Lensmakers formula? Most of the questions are going to come from this formula. That is why. 5 minutes for everyone to look back at the class and come back. I'll be back in 5 minutes. Okay, then let's begin. Let's begin with the question that I asked you. What is mu?
Refractive index with respect to air.
No, that is not correct. That is the problem. That probably you have not. Has any one of you written notes of whatever I have been telling you? Anyone? Anyone has made a notebook with notes? Please raise hands. Everyone is writing everything on sheet and not everything, obviously, because if they had written everything on the sheet, it would have been obvious that mu is the refractive index of the lens with respect to the medium surrounding it. And I have told you that at least 5 times in the last class, but you don't seem to pay attention. There's something wrong with the way I'm teaching, probably. But if I have told something 5 times, 6 times, and you can't recollect it on the next day, that's a big red flag. Mu again and again and again and again and again is the refractive index of the lens, the material of the lens, glass or whatever it is, with respect to the medium which is surrounding it. Mu is the refractive index of the lens with respect to the medium surrounding it. In other words, it is refractive index of the lens divided by refractive index of the medium. Will you remember it now?
Yes, sir.
Okay. That takes us to the beginning of this class, and I probably gave you a question to solve. Did anyone do it? Did anyone attempt to solve the question that I gave you to solve? Yes or no? Yes, I have one raised hand. Okay, great. If you have attempted it, that is good. Well done. I also asked you to look at the special cases that are given in the sheet. Have you gone through those special cases? Anyone? No one? Okay. Well, in that case, in any case, we'll have to do all these special cases, and we can start with the special case of focal length of a equiconvex lens. Equiconvex means both the radius of curvature or radii of curvature. Here, if you can look, the radius of curvature of this surface, the first surface, as you can see, object is placed here. So this surface becomes our first surface, and this surface becomes our second surface. Do we understand this? The
Yes,
radius
sir.
of curvature of the first surface will be positive because it will be in the same direction as incident light. But for the second surface, which is like this, the radius of curvature R2 would be negative. So here I have R1 is written as plus R1 and R2 is written as minus R. Both are same. Radius of curvature or radii of curvature are same. So one is written as plus R and the other one is written as minus R. Do we understand this?
Yes, sir.
Then we find the focal length. Which focal length are we talking about? We are talking about the second focal length, mu minus 1. Here mu is the refractive index of the lens with respect to the medium. The medium is air, so we simply use the value of mu, mu minus 1, and then I put r, the radius of curvature, with sign convention. It's 1 by r1 minus 1 by r2. R1 is plus r, R2 is minus R. So we have one more minus sign here. Minus minus becomes plus. So it becomes 2 by R. If I solve this, this will be the focal length. I can understand that it may be difficult for you to remember the formulae of all the focal lengths in different cases. But you must remember one thing, that all these formulae are derived from the Lensmaker formula by putting different values of mu and different values of r. So all these formulas are derived from the same formula. You don't have to remember each and every individual formula. If you can remember the formula in the box, you just have to put the values of what? The values of R1 and R2. Remember, in case of a convex lens, both the values of R1 and R2 would be positive. Do we understand this?
Yes, sir.
Paka? I'll give you a minute to note it down. Case number 1.
Okay, sir.
We have seen, if I place the object on the left hand side, the focal length is given in black. It is a convex lens. If the object is placed on the right, what will be the focal length of this lens? Anyone with any answer? In this case, what will happen? This will become my R1. This focal length would be positive, and this focal length would be negative. Yes or no? Ah, radius of curvature of this surface, which will be the first surface, it will be positive. Radius of curvature of this surface, which will be the second surface, would be negative. So R2 becomes R1 and R1 becomes R2. Do we understand this? But their signs also change. So instead of R1 over here, I will have plus R2 over here. Instead of R2 over here, I will have minus of R1, but minus of R1 and minus of R1 becomes R1. So whether I look it from here or I look it from there, in both the cases, it is going to behave as a convex lens. Its focal length will be coming out as same. It doesn't matter where you keep your object. A convex lens remains convex no matter where you keep your object. The focal length remains same. The focal length does not change if the object is placed from one side to the other side. Focal length does not depend on where the object is placed. Focal length depends on the value of mu. Refractive index with respect to the medium, it depends on the value of R1. It depends on the value of R2. Do we understand this?
Yes, sir.
That is the first point. And remember here, star, if R1 is equal to R2, both are same, this becomes a EQ convex lens. Do we understand this?
Yes, sir.
And in the case of an EQ convex lens, you put both R1 and R2 as R. You will get the answer for the value of mu, for the value of F. And in that case, if I am correct, if my calculations are correct, this will be equal to 2 R upon 2 times mu minus 1. Or I have written it ulta. That will be the focal length for a EQ convex lens. Do we understand this?
Yes, sir.
Please note it down. Then I can ask you a simple question. We have seen that the focal length of a lens does not depend on the position of the object. Now let us suppose that I have a convex lens in air. Can I do something without changing the shape of the lens, without changing the material of the lens? Can I do something that a convex lens becomes a concave lens? I cannot change the shape of the lens, obviously. I cannot change the material of the lens, obviously. Is there anything in this world that is possible to convert a convex lens to a concave lens? Obviously, by changing the position of the object, it's not going to work because we have already seen that. Is there any other way of changing what? Of changing the nature of the lens? Can I change the nature of the lens? Let us do it with the question. Question number 1. Let us do it with the question. Question number 1. And what is this question number 1? A lens of refractive index mu, which is equal to 5/3. Remember, refractive index of any material with respect to air will always be greater than 1. A lens of refractive index mu is placed in air. It's a EQ convex lens. So radius of curvature, I call it radii. Radii is the plural of radius. Radii of curvature of both sides is same. It is equal to R. The question is simply find the focal length. Can you find out the focal length of the lens in air? Remember, whenever you are talking about the focal length of any lens, you must specify in which medium are you talking about the focal length. Here, I am talking about the focal length of the lens in air. I'll give you 2 minutes to solve this problem. Your answer will be coming in terms of r, where r is the radius of curvature. If it is 10 centimeter, you replace r by 10. If it is 20, replace it by 20, and so on. Can you solve this question for me? Are you confident that you can solve this question for me? Yes or no?
Yes, sir.
Then you will have 1 minute, sir. Oh, I did not share the screen. So the question is on the screen. You can see, you can see it, that you can see this question now. The lens, a lens of refractive index 5/3 is placed in air. Both the radius of curvature or radii of curvature are same. It is given as r. Find the focal length of the lens in air. I hope the question is right now on your screens, and I'm giving you a minute to give me the answer. The radii of curvature are given as r, and the lens is given as a convex lens. You can see that. Looking at the diagram, this lens is a convex lens. Can you tell me what will be the focal length of this lens? Anyone with an answer?
F is equal to 3r by 4.
3r by 4 is the answer I have got. Let us check whether this answer is correct or not. This thing has malfunctioned. Okay, I will just correct it. I hope it works now. Machines, they give you trouble sometimes. So how do I do it? 1 by f will be equal to mu. Here the mu will be refractive index with respect to air. So I just use the value of mu as 5/3. Do we understand this? 5/3 minus 1 into 1 by r1. Here r1 is r. Is it positive or negative? This r would be positive, yes or no?
Yes, sir.
Minus 1 by r2. Now r2 wala r is positive or negative? It is negative. Yes or no? Do we understand this?
Yes,
This
sir.
r is positive and this r is negative. Everyone there with me on this?
Yes, sir.
I put the values and see what is the answer. 1 by f will be 5/3 minus 1 would be 2/3. Yes or no? And this will be 2 by r if I solve it. So my final answer for the value of f, would be 3/4 r. All of us getting the same answer?
Yes, sir.
Is this value positive or negative? Obviously, this value is positive. What sort of question is this? So this will behave as convex lens in air. It is definitely a convex lens in air. Do we understand this, everyone?
Yes, sir.
Can I have raised hands from everyone in the class? Okay. Now, if you remember, my original question was, can I make this lens concave? Can I do something to make this lens convex? Now, that is the second part of the question. So how do I make the second part of question? So this is the second part of the question. If I call this question as part A, now I am making part B. If this same lens, if the same lens if the same lens is placed in a medium of refractive index mu, which is 2. Here, refractive index is 1, but now I have placed it in a medium where refractive index is 2. Find out the focal length. Can you do this for me?
Yes, sir.
You will have 2 minutes to give me the answer. So,
Mi-
yes, beta,
Yes, sir.
it's coming as plus R.
Minus
Pakka.
R.
It's coming as minus R. Now you have changed your stance. It's coming as minus R. Pakka it is minus R or something else. Okay. Let me have a look at it. Again, I start the solution. I start the solution and I put the formula. 1 by f would be equal to mu. Now this mu is a refractive index with respect to the medium. So 5 by 3 divided by the refractive index of the medium. So 5 by 3 divided by 2. How much is 5 by 3 divided by 2? It will be 5 by 6. Yes or no?
Yes, sir.
Minus 1 multiplied by 1 by R1. Here R1 is positive. It will be taken as R. Yes or no?
Yes, sir.
Minus 1 by R2. Here R2 is negative. It would be taken as minus R. Yes or no?
Yes, sir.
If I solve this, 1 by F will be equal to 5 by 6 minus 1. 1 by R plus 1 by R is 2 by R, my dear friends. Yes or no?
Yes, sir.
Did everyone reach up till this point?
Yes, sir.
If from here you can't find the value of F, I can't help you out. What is the value of F coming from here? Tell me, bacha. What is the value of F coming from here? No answers?
And then
Yes, beta? Not confident enough to solve this? Yes?
3R.
3R. You again missed the most important point. The point which I was trying to make. It will be coming as minus 3R, my dear friends. Minus. That is the most important point that I was insisting on. Minus.
Okay, sir.
Well, I'm very sad that you could not solve this. Really very sad. Anyways, my sadness has got nothing to do with the class that I'm taking. My sadness is a state of mind. I could be sad, but you are happy, so doesn't matter. Minus is what I was insisting on. This lens, which was obviously convex in air, has become concave in this medium. The nature of the lens has changed. Now, may I ask you, why has the nature of the lens changed? Can anyone tell me that? I hope everyone is in the class listening to me. Questions are going to come from this, and the same questions which I'm going to ask now, which I'm asking now, will come. What made the lens change its nature? It was convex. It's looking convex in air. It was convex in air, but if I change the medium, well, my answer is coming negative. Does it become concave? That is question number one. If it has become concave, why it has become concave? Can anyone give me the answer? First question, please answer the first question first. Does it really become concave? Do you believe this, that it is becoming concave? Yes or no? It's a binary question. Either it is yes or it is no. Does it become concave?
Yes, sir.
Yes, it becomes concave. Are you confident about it?
Yes, sir.
Okay. Now the second question comes. The answer to first question is correct. It definitely becomes concave. Now the second question is why it has become concave?
Radius curvature is negative.
Awful answer. Radius of curvature has not changed, my dear friends. It was 1 by r. Radius of curvature r1 was plus r there also. Here also. Radius of curvature r2 was minus r there also. Here also. Find some other reason. Why it has become concave? What is the other reason it has become concave? I have not changed the radius of curvature. No. The lens remains same. Why it became a concave lens? Can I have your answers, please? Well, the answer is in the question itself. I've placed it in a different medium. The nature of the lens changed because I have changed the medium. I've changed the medium from air to a medium where refractive index is 2. Now, what significance this 2 has? If you look at, and please note it down, if you look at, if you look at, if you look at what? If you look at the refractive index of the lens, refractive index of the lens was 5 by 3. Refractive index of air was 1. So, with respect to air, lens was denser. It remained convex as it was supposed to be. It was convex in air. But when I change the refractive index of the medium to 2, remember, refractive index of the lens was still same. It was 5 by 3. It was 5 by 3. Here I have changed the refractive index of the medium to 2. Are you following me, everyone?
Yes, sir.
What really that has changed? I have placed it in a medium whose refractive index is more than the refractive index of the lens. Do we understand this?
Yes, sir.
Again, I will repeat. And please put your heads down and write. What I have done here is I have placed this lens in a medium which is denser than the medium of the lens. This medium is denser as compared to this medium of the lens, the glass of the lens. This is a rarer medium. I have placed the lens in a denser medium. Do we understand this?
Yes, sir.
If I place the lens in a denser medium, and that is the point that you will write, if the lens is placed in a denser medium, what happens? Can anyone complete this statement? If the lens is placed in a denser medium, then what happens? Can you complete the statement now for me? For everyone in the class? Anyone? What is the statement? If the lens is placed in a denser medium, can you complete the statement? I'm waiting. Yes. No answers are right or wrong. You have understood something here, right? Please tell me what you have understood.
Rarer is greater than denser.
Rarer is greater than denser. Okay. If the lens is placed in a denser medium, then the nature of the lens changes. Then the nature of the lens changes. That is the statement that we are looking at. When I say the nature of the lens changes, what do I mean by that? Is if it is a convex lens in air, it will become what? A convex lens will become a concave lens. A concave lens will become a convex lens. Do we understand this?
Yes, sir.
I'll give you 2 minutes. Please note it down. Then we will move ahead. I hope you have understood what I have just told you. We have done this part. Then we move on to the next type of the lens, which is this one. This is a Plano convex lens placed in air. Do we all see this? Object is placed here. This side of the lens is convex and the other side of the lens is plane. This radius of curvature is R, which is taken as positive. The other radius of curvature is for a plane mirror of a plane lens, and this radius of curvature is infinite. Do we understand this? One side is convex, radius of curvature is plus R. The other side is plane, the radius of curvature is infinite. Do we understand this?
Yes, sir.
We find the focal length of this lens 1 by f is equal to mu minus 1 by r, 1 minus 1 by r2. The value of r1 is plus r. The value of r2 is infinity. 1 by infinity is 0. Therefore, the focal length of this lens will come like this, r upon mu minus 1. In this case, they have also told us what will happen if I place the object in front of the plane portion. Even if I place it in front of the plane portion, the focal length remains same. Do we understand this?
Yes, sir.
I'll give you a minute to note this down in your sheets. Then let's move on to this question. And instead of giving this question in words, I'm giving this question in figure. What type of lens is this?
Biconcave.
Yes, it's a biconcave lens. This side has a has a radius of curvature r. This side has a radius of curvature r. So both the radii are same. So this becomes a EQ convex concave lens. Do we understand this? It is made up of glass, and the refractive index of glass, remember, it is equal to 3 by 2. Will you remember this? If even if you don't remember this, it will be given in the question. It is made up of glass whose refractive index is 3 by 2. It is placed in air. So question number 1 is, it is placed in air. You have to find out its focal length. It is placed in a medium of refractive index 2. You will have to find out its focal length. So this is question number A, where it is placed in air. Then this is question number B, when it is placed in a medium of refractive index 2. I'll give you 2 minutes to solve this problem. Can you do that for me, everyone?
Yes, sir.
Let's see who gives me the answer first. Your time begins now. Let us go ahead and solve this question. I hope everyone is there with me. Can I have some raised hand that everyone is looking at the board? Girls, boys, everyone? Okay. Now the first thing is you have to tell me whether this R is positive or negative. That is the first thing.
Positive.
No, this R is negative. This is a equiconvex concave lens. The center of curvature lies here, and this is how you will measure it. So this R becomes negative. Do we understand this? This R becomes negative. What about this R? Is it positive or negative?
Positive.
This R is positive. That is correct. So R1, this is R1, surface 1. This R is negative. Surface number 2, R2, this R is positive. Is everyone following me? Can I have some raised hand that everyone is following me?
Yes, sir.
Okay. I now put the formula 1 by F is equal to mu minus 1. I'm writing the formula once so that all of us understand it. 1 by R1 minus 1 by R2. I've written the formula. Now in the next step, I will just put the values. 1 by F will be equal to mu. I have to find its focal length in air. I use the value of mu as mu. So this will be 3 by 2 minus 1. 1 by the value of R1 is plus R. So I take plus R minus 1 by minus R. Do we understand this, beta?
Yes, sir.
I move on to the third step. 1 by f will be 3 by 2 minus 1 is half. 1 by r plus 1 by r is 2 by r. R say R will get cancelled. And I have the final answer. Oh, I have probably done a mistake here. This R was negative and this R was positive. Sorry for my mistake. Sorry for my mistake. So this will be coming as minus 2R. My F would be coming as minus R. Minus sign indicating that this is a concave lens. Do we understand this? I've done a mistake. R1 is minus R and R2 is plus R. I just used the thing for convex lens. That was the mistake on my part. So minus R, minus 1 by R, minus 1 by R becomes minus 2 by R. 2 and 2 getting cancelled. Focal length comes as minus R. That means this is definitely a concave lens when it is placed in air. Anyone has any doubts on the steps that I have done? Well, I'll give you 2 minutes to note it down. Also, can you now attempt part B for this question? Can you do part B for this question? Yes or no?
Yes, sir.
So please note down this part and then attempt part B. This is question
B,
number.
sir. B.
Oh, you have the answer. Great. I could not even read the question, but you have the answer. Let me read the question for my own benefit. Two spherical surface of a double concave lens have the same radius of curvature r. The refractive index of the medium is mu. What is the focal length of the lens? That is the question. And can I have your answers? This is question number 5. Remember, it's a double concave lens. May I have your answers now? Is everyone solving the question?
Yes, sir.
Okay, so what is the answer? I'll give you a minute to think about it. Heart beta, the answer is 3.
C, Corona.
C, not B. Remember, it's a double concave lens, not convex. If it was convex, then the answer was B. It is concave. It has to be negative. Therefore, you have 1 minus mu. Negative of mu minus 1 is 1 minus mu. And that is why the answer is C. Do we understand this?
Yes, sir.
Be careful because you should not lose marks on these small things. That takes us to the next question. And this is question number 6. A thin lens is made with a material having refractive index mu 1.5. Both the sides are convex. We are talking about air. It is dipped in water whose refractive index is 1.33. It will behave like A, B, C, D. And if you remember what I have told you, you should be able to give me the answer. Now, what is the answer? Question number 6. What type of lens it will behave like?
Convergent lens, sir.
It will behave as a convergent lens. The reason is in air it is a convergent lens.
Convex lens, yes, sir.
In water, refractive index of water is 1.33, but the refractive index of the lens is 1.5. It is more than the refractive index of water, so its nature will not change. If the answer would have been, it is placed in a medium of refractive index 2, then what would be the answer? If I would have changed the question and made the refractive index as 2, then what would be the answer?
Divergent.
Then the answer would have been divergent lens, because now it would be placed in a denser medium. But the original question, it is still placed in a rarer medium, and therefore the answer to this one is A. It will still behave as a convex or a converging lens. Can we move ahead in life with the next question? Shall I move ahead, or do you need more explanation on this? When it was in air, it is convex. It is placed in another medium, it may change its nature. But this medium is having refractive index of 1.33, which is less than 1.5, and therefore it will still remain a convex lens. Do we understand this?
Yes, sir.
That takes us to the next question. And let's see if you can answer this one. This is same question but put in a different way. Let's see who can give me the answer for this one. Are we there in the class, everyone? I hope in physics class, all of us are studying physics and not chemistry or biology. Because if you are doing this, you will not be doing good in chemistry or biology or physics. Physics class, study physics. Chemistry class, study chemistry. Biology class, study biology. Your mind can only do one thing at a time. You cannot multitask. And the question is like this. A convex lens of refractive index 1.5 is immersed in water. So I put it in water. What will happen to its power compared to its power in air? Does it increase? Does it decrease? Does it remain same? Or it cannot be predicted? Can I have your answers, please? Power of a lens. And the answer is 2, my dear friends.
Bombay.
Do we know this, or did I give you the answer before you gave me the answer? I thought that I saw 2 somewhere, and that is the answer. Its power decreases.
Decreases
Now,
in water.
its power decreases in water. How did you get the answer, beta? So, remember, power.
Practical logic.
Yes, beta? How did you get the answer, beta?
Some logic.
What logic? Can I understand that logic, please?
My friend's by concave specs is I have put in water, sir. Its power is decreased.
Okay, okay, so you have, it's not logic, you have done it practically, but let me make you understand how, why the answer is decreases. So 1 by f is the power of the lens. Do we understand this?
Yes, sir.
Okay, now the formula for power of the lens is mu minus 1 multiplied by something something. Yes or no?
Yes, sir. Something,
Okay,
something.
something something 1 by r1 minus 1 by r2, whatever it is. Now when it is in air, when it is in air, when it is in air, its refractive index is with respect to air, that is 1.5. But when I put it in water, its refractive index is with respect to water. Now when you have the refractive index with respect to water, it will be 1.5 divided by the refractive index of water, which is 1.33. Are you getting my point, bacha? So instead of 1.5, it is 1.5 divided by 1.33. The value of 1.5 divided by 1.33 will be less than the value of 1.5. Do we understand this?
Yes, sir.
Since the value of 1.5 divided by 1.3 is less than the value of 1.5, the value of power will decrease, and hence the option is option B. Can I have raised hands from everyone that we understand this logic? The logic is very simple. When I dip it in water or any other medium, the refractive index comes down. Please remember this. The refractive index with respect to medium comes down, and therefore the power of the lens goes down. Now, instead of power, if I would have asked what happens to the focal length of the lens? Does it go up? Does it go down? Does it remain same? Or I cannot tell you, I don't know. What about the focal length of the lens? If I change the question to from power to focal length, can you give me the answer to the question now? What happens to the focal length of the lens? Does it increase? Does it decrease? Remain same? I don't know, sir. I am new in the town.
Increases.
Yes, my dear friends. Power decreases, but focal length increases. Remember, one of this question might be coming in the paper, and that time you should remember this. Can I trust you that you can remember this? Yes or no? No or yes? I'm not getting answer. Okay. Here comes the next question on the Lensmakers formula, and this is the another type of question. Now remember, all questions are solved with the same logic. There is no other formula. There is no other logic. There's just one formula, and there is just one logic. Can you solve this one for me? The focal length of a convex lens of glass, obviously, in air is 2 centimeters. The refractive index is 1.5, not of air, of the glass. The focal length of the lens when immersed in a liquid of refractive index 1.25 will be how much? 1.25. How much will be the answer? And your time starts now. Can I trust you that you can solve this? Do you have the confidence that you will be able to solve this?
Yes,
Yes.
sir.
Well done, sir. That is the confidence that I need. You have 2 minutes, and maybe when I solve this question, I'll give you a shortcut formula as well. You can remember the shortcut. Very good. If you can't, you can always solve it with your own logic. And I like the logic, putting something in water and actually seeing what is happening. Well, you will not have a water bucket and a glass to put it and see it in the examination hall. So let us not do the practical part now. Let us concentrate on the theory one right now. 2 minutes. Now let us see how are you going to solve it. And please have a look. You can also note down this formula as a shortcut formula if you want to. Solution for this problem. Now, if I write the focal length of the if I write the formula of focal length, let me write it as air. 1 by focal length in air is mu air. So mu A, mu in air, or I simply write it as mu so that you don't confuse it. Mu A, mu minus 1 into 1 by R1 minus 1 by R2. I don't think you have any problems with this formula. This is the formula that you use. Yes or no?
Yes, sir.
Now 1 by focal length in the medium. Now what will happen in this if instead of mu, you will have mu divided by mu of medium. Yes or no? No or yes?
Yes, sir.
Minus 1 into 1 by R1 minus 1 by R2. What do? I divide these two equations. I divide these two equations. When I divide these two equations, what I get? On the left hand side, I will have focal length in the medium divided by focal length in air. Do we understand this?
Yes, sir.
That will be equal to mu minus 1 divided by mu m minus 1. Now this becomes your shortcut formula. This becomes your shortcut formula to calculate the focal length in any medium. So I can write this formula in this way. Focal length in the medium will be equal to focal length in air multiplied by mu minus 1 in numerator divided by mu m minus 1 in the denominator. Can I have some raised hand that we understand this from everyone in the class?
Yes, sir.
Now we come to the final step and write the values for this given question. Focal length in the medium will be equal to focal length in air. I think that is given as 2, yes or no?
Yes, sir.
Multiplied by mu, which is the refractive index of glass or the lens, that is given as 1.5, yes or no?
Yes. Yes, sir.
1.5 minus 1 divided by 1.5 divided by 1.25 minus 1. You just need to solve this thing. It is not as complicated as it is looking like. As you can see that this will be equal to 2. In the numerator, you will have 0.5. Do we understand this?
Yes, sir.
Divided by, this will come in the numerator and everything will be going up. So this will be 1.5 minus 1.25 multiplied by 1.25. Do you see how I have done this, bacha?
Yes, sir.
That's it. 1.5 minus 1.25 will be 0.25. So I move on to the next step. So 2 multiplied by 0.5 multiplied by 1.25 divided by 0.25. And now this is very simple to calculate. This will go 2 times. 2 times 2 becomes 4. 4 times 1.25. And your final answer is plus 5. Do we all understand this?
Yes, sir.
So I have deducted or deduced this formula. With the help of this formula, you can find the focal length of any lens in any medium if you know the focal length of the lens in air. Can I have some reason that we understand this?
Yes, sir.
Well, then that brings us to an end for this class for today. What we have done in today's class, we have not done anything new for that matter. We only discuss questions based on Lensmakers formula. This is a very important topic, Lensmakers formula, and you will always have questions coming from this particular topic of Lensmakers formula, and therefore we have given it enough time. I hope you have understood this. There are 2 or 3 more questions in the sheet on the Lensmakers formula, which I hope that you can do it for me. Can you do it for me? Yes or no? Just to
Yes, sir.
summarize the main point, when you have a lens and you dip it in any other medium, the focal length and the power both changes. If you put it in a medium which is more denser than the lens, the nature of the lens will change. Convex will become concave, concave will become convex. In any case, the focal length, if you dip it in any other medium apart from air, the focal length will increase and the power will decrease. On that note, I will dismiss the class for today. I hope you liked the class. Till next time, till tomorrow. Tomorrow we will be going ahead and doing more important points. And those important points are basically questions that are going to come in your exam. We will discuss them in the next class tomorrow. Take care. Have a nice day. Bye bye.
Take care.